Microphones are wicked interesting. Sorry, I'm eating a grapefruit. I know that there's like a bajillion videos on YouTube about microphones, but most of them are like, what microphone should I get for podcasting? How do I plug 6 USB microphones into my Chromebook? Help, my microphone's pregnant. And all of that's great, obviously, but it kind of misses some of the fundamentals about what makes microphones so cool. I actually don't think it's grapefruit time. I think... All right. It might seem counterintuitive, but I think the best place to start understanding microphones is by understanding speakers. So this is a speaker, and its job is to take an electrical signal and turn it into sound waves. Copyright-free sound waves. The way that it does that is so cool, and I can demonstrate it more easily by showing you a really low frequency sound. This is below the range of human hearing, but you can see that it makes the speaker move quite a bit, so it's pretty good for this demonstration. And this is all that a speaker is ever doing. It is taking that waveform that you see on the computer and moving in physical space the exact same way. When the waveform goes up, the speaker goes up. When the waveform goes down, the speaker goes down. You might have noticed it wasn't perfectly in sync with the screen. We'll touch on that at a different time. So how does it do that? Grapefruit is like embedded in my mustache. It's actually really simple and it's really cool. On the top of the speaker, we have a paper cone or a rubber cone. That's the part that actually moves physically to recreate the sound waves that we hear. Underneath the cone is a coil of wire called the voice coil that is glued to the underside of this paper cone. Beneath that cone and the coil is a big permanent magnet. That's all there is to it. So how does all of it come together to make that happen? When you send an electric current through a coil, it turns into a magnet. Maybe you did an experiment in school where you connect a coil of wire to a battery, use it to pick up paper clips. The computer is sending the audio signal to this coil, which makes it into a magnet, but a magnet that keeps on changing up and down. The middle of the line of a waveform graph is 0. And anything that's above that is the positive portion, and anything below it is the negative portion. So in the speaker itself, we got that big permanent magnet at the bottom with a positive side and a negative side, and that stays still. Floating above it is the coil right here. When the computer sends a waveform that goes positive, these two are going to repel each other. When the computer sends a waveform that is negative, these two will attract each other. And that is exactly how you get the motion of the speaker. That's how speaker work. Magnets repel and attract each other. What does it have to do with microphones? This is a microphone. That's the exact same thing as what's going on in here. There is no difference. I mean, like, they look different. They're like, it's a different shape. Electrically, electromechanically, these are identical. And actually, I can't do it with this one because it has an amplifier attached to it and all this other circuitry, but headphones are just speakers that you strap to your head. If I take these headphones and plug them into an input on my computer, and I hit record, I can actually talk into these headphones, and it will record me just like that, like a microphone. There's no trickery going on.
This is the audio from the headphones, and it's obviously not great. They weren't meant to be used as a microphone.
Also, just in case you didn't think it worked the other way around, if I take this microphone and I plug I'm not faking this. Also, you shouldn't do this. It's extremely bad for the microphone, and you'll probably burn out the voice coil. You can probably cut or not. We can keep going. What do you think? Am I good? Okay. There's no fundamental difference between these, and that might seem like magic, but it's literally the same thing we talked about before with the magnets. Instead of the coil wiggling the cone using magnets, you're wiggling that cone with your voice, and that's moving the coil past the magnet, which generates a small electrical signal in the coil, which we can measure. A dynamic microphone is just a speaker backwards. That's what a dynamic microphone is. There's a lot of other kinds of microphones, and they don't all work the exact same way, but that basic principle is true for all microphones. You are wiggling some kind of a diaphragm with your voice, which is being detected electrically some way, and those wiggles translated into the wiggles that you see on a screen. And if you are the Wiggles and you're singing Wiggles songs into it, the wiggles that you're making are the Wiggles wiggles. Does that make sense? How much of the shot can you see? Am I focused? Do you need that? Okay, there are a lot of different kind of microphones. There are a lot of different kinds of microphones. The two you'll probably hear the most about are dynamic microphones and condenser microphones. We're gonna talk more about condenser microphones in this video, but there are also laser microphones, which you've probably only ever seen in spy movies if you've seen it all, where they will literally bounce a laser off of a surface like a window or something. And if I'm on the inside of this window and I'm talking and making the window vibrate, they can measure the vibrations of that laser beam at the far end and tell what I'm saying. There's also electret microphones, like this lavalier microphone or the other lavalier microphone. I have one to show. I know it's on.
The other lavalier is not out.
Oh, that's an electret microphone. It's the same thing as a condenser microphone, but really small. And instead of needing power, it has a little piece of plastic with a permanent static charge in it, which is really cool. We'll probably do a whole video about them. The kind of microphone that's in your phone is a totally different kind called a MEMS microphone. And those are like printed circuit chips. They're teeny tiny. I got it. They're like little tiny chips with the microphone built right in. That's what's in a lot of small devices nowadays. It works kind of like a condenser. And then there's weirder ones like piezoelectric microphones, which use literal crystals. But we're focusing on the most common ones. We've already covered dynamic microphones because they're the same thing as speakers. Let's talk real quick about condenser microphones and what makes them different.
Science rules! I love science.
So this is a condenser microphone. This is an MXL 990. I actually think my dad got it for me when I was a teenager. Oh no, I stole this from Ian Kazakchek. He was gonna start a podcast. It was 12th grade, and I was like, can I borrow your microphones? And I never gave them back. I need to find out Ian's contact information and send him some microphones.
Ian, if you're watching.
Yeah, I'm so sorry. And I'm gonna take it apart. So right off the bat, you can tell that it's a more complicated piece of hardware, right? Because we have this whole little printed circuit board here that's got a lot going on. And then the actual diaphragm of the microphone, the cone, if you will, is very different. You have two thin metal plates that are suspended like, I don't actually know how far apart they are, but it's not like they're real close. Condenser microphones require power fed to them through their XLR connector to power up this circuitry. That's what phantom power is. They're called condenser microphones because that's what we used to call capacitors back in the day. Those two plates are given an opposing charge. So I know this was our magnet from earlier, but imagine one of the plates is charged up positive and one of the plates is charged up negative. When your sound waves hit the plate in front, it moves ever so slightly closer to the plate behind it, and that creates a change in its electrical capacitance. So instead of a coil moving past a magnet, we can kind of see how those charges between those two plates are fluctuating. Why would we do this, even though it's wildly more complicated? There's a big advantage to having a very thin metal plate that doesn't move very far. Think about high frequency sounds. Anything that's really high in pitch is vibrating very quickly. A lower pitch sound moves slower, higher pitch sounds wiggle faster. This is so much better at picking up higher frequency sounds because there's almost no mass to move. With a speaker, with a dynamic microphone, you have to be moving that diaphragm back and forth with your sound wave. Your wave has to do more work. With this, my sound wave just kind of touches it, and we're measuring such an infinitesimally small amount of movement, you can get a much more precise signal and pick up higher frequencies more easily. That's why capacitor microphones, what am I, from the 1940s? That's why condenser microphones are so sensitive. Every little sound wave has to do less work to be heard. We'll get into that stuff in future videos. The main thing you need to take away is that a dynamic mic is really simple. It's got a cone, a coil, and a magnet. A condenser microphone requires phantom power to power up this circuitry, which amplifies the signal coming off of the capsule. Any question? I had like way too much to get to. There's like so much more that I wanted to cover. I have to get into wave interactions and like, I just want to lay the groundwork, like the foundation that everything gets built on, because it gets really complicated, but the stuff that we started with is pretty simple, and I feel like we're getting there, but we're gonna probably need some more videos. So I think we'll just call it there for now. I like the main thing, as long as you took away that the wiggles from your voice make wiggles on something physical that make wiggles electrically, and that these are all the same wiggles and how they're represented, that's the meat of what I wanted to cover. And there's gonna be a lot more of this in the future. I guess I have to ask people to subscribe. Like and subscribe, comment, I just think microphones are wicked interesting. And if you do too, make sure you hit the like button, leave a comment, let me know the thing you thought was most interesting, or something that surprised you that you learned in this video, or suggestions for the future, or maybe I got something super wrong. Leave a comment, subscribe to the channel. I'm gonna make some more stuff. I wanna share it with you. I want you to be a part of that. It'll be cool. It'll be nice. It'll be neat. It'll be wicked interesting. Is that how you do it? Thanks for watching.
Comment what fruit you want to see me eat.
Oh yeah, comment what fruit you want me to eat.